actually understood what I was trying to convey. Because your answer is the only way to minimize the gap that we are facing in this pandemic. How many of you understood? So I was talking about a recursive way to to generate strings, and a recursive way to not to generate. I'm sorry. A recursive way to generate sub expressions, and join them with operators to create bigger expressions, and to create such expressions for all strings that take you from some state I to some state J, right? So it's an algebraic way to create an algebraic expression to denote all strings that take you from some state I to some state J. Now, remember, whenever I say some, it should be general enough so that it applies to every state in the diagram. Done? Now, the next issue is how to do that. How to be sure that if you start at some state I and you end at some state J, you are actually taking care of all strings that take you from I to J. Then I talked about two possible options. So two possible options is if you are intending to start at I and end at J, there are two possible options. One possible option is that you go via direct links from I to J, or talking otherwise, you go over strings from I to J directly, or you land up in some intermediate state.
Sir, are you writing?
Sir, your board is, sir, you haven't shared your board.
Okay. I'm sorry. Yeah, I'm sorry. Now, are you able to see?
Yes, sir.
Yes, sir.
Okay. Thank you. So let me start from the beginning, whatever I was saying. Okay. So that there is no confusion. We need to understand properly, because these are building blocks in your endeavor in computer science, right? So what I was telling is, you have a state I and you want to go to state J, right? Now you have to take care of all possible strings that take you from state I to state J. Now you have two options. One is a direct link from I to J. This is option number one. If you at all have a direct link from I to J, you need to take care of that. Additionally, you need to take care of strings that go via some intermediate states called K, right? There are only two options. You can directly go from I to J, or you can go from I to J via K. Now this via K is a very important factor. As soon as I say that it goes via K, I should have a mechanism to mathematically justify that K is somewhere in between I and J. Now the only mathematical justification for that is to rename I to some state with number 1, K with some state number 2, J with some state number 3. And only if you have this order, that 3 is greater than 2 is greater than 1, only then you can say that, okay, I start at state number I, that is 1. I want to go to state number J, that is 3, and I'm going via state number 2, state number K, that is 2, right? So only when you number in such a way that that numbering system is inherently ordered, and the most simple form of inherently ordered system is the set of natural numbers, right? So the idea is to rename the states with numbers so that you can justify your claim of K being an intermediate node. So what I say that, okay, if you start at I and want to go to J, then there are two options. You can directly go to J without going through any state, or you can go to J via some intermediate state K, right? Now, I increase the complexity by drawing something more conceptually, that in K, you may have repetitions, or even from K, you can go back to I, right? So now what are the strings? One particular type of string is the direct string that takes you from I to J, if that exists, or it should be taking you through K to J like this, or it should be taking you to K and repeat more than once if there are loops. And even if there are cycles back to I, it should follow this road and generate more and more strings, more and more strings, more and more strings, and then go to J. There are two options. You can directly go to J without going through any state, or you can go through any state, right? Now, to generalize this whole concept, a structure is defined that represents the strings that take you from the strings that take the expression for the strings that take you from I to J, and labels are defined. Those labels work in a recursive way. They are defined in a recursive way, so that they are defined recursively. Those labels are called Ks, where I, J's, and Ks all belong from the set of natural numbers. So what we mean is Rijk is an expression, right, to represent all strings that take you from state I to state J, but not going through any state numbered higher than K. So Rijk is an ensemble of all strings that take you from state I to state J, possibly going through the kth state. And as soon as I say that this is an expression that gives you all strings that take you from I to J, possibly going through the kth intermediate state, I mean that I include all strings that take me from I to J via states K minus 1, via states K minus 2, via states K minus 3, via states K minus 4, and actually via states 0, right? Got the point? So what is the interpretation of this expression? It says that it's an expression, it's an algebraic expression representing all strings that take you from I to J, but not going through K plus 1 or higher. It should not go through K plus 1 or higher. So one alternative way of definition that you find in books is not going through a state higher than K. And as soon as I am able to establish this expression, I mean that if I say that I have Rijk, it means that I already had Rijk minus 1. That in turn had K minus 2. That in turn had K minus 3. That in turn had K minus 4. Dot, 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 dot. That in turn had 1. And that in turn had 0. Right? This is how. So what I mean is, if I talk about strings that take me from state I to state J, so Rijk means that I have already taken care of all strings that take me from I to J via the highest intermediate state as K minus 1. And once I had K minus 1, it means that I should have had K minus 2. If I have K minus 2, it means that I should have had K minus 3, like that, to 0, right? The recursion ends here. Or talking in another way, it's easy to visualize and define the 0th term, that is Rij0, and then based on the value of this 0, if it is possible to define 1 and then define 2, then define K minus n like that, and then define K minus 1 and then define K, with the confidence that if I say that I have an expression for Rijk, that means I have taken care of all such below me. Got it? So how to define Rijk? Now see, I have generalized this two state and very simple transitions to in terms of I, J, and K. So how to write Rijk? You write Rijk recursively as Rijk minus 1, Rk minus 1 star Rkjk minus 1 plus Rijk minus 1. This is nothing but a pure generalization, algebraic generalization of this simple picture. So in this simple picture, we had only two states I and j, and we had a direct transition from I to j. There was no intermediate state, or we had at least one intermediate state that has a circle or that had a way back to I. So that was the most simple form. Now I generalized to take care of even complex diagrams with Rijk. So this portion says that I go from I to j, not going through any state numbered higher than k minus 1, right? So Rijk minus 1 gives me all strings that take me from I to j going through at most k minus 1. That means I have taken care of all strings that take me from I to j going through k minus 2 dot 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 0. This or this. That means from I go to k, from I go to k, and from I go to some intermediate states via the highest intermediate state numbered as k minus 1. In k, I take care of all circles. I remain in k. I start in k and I end in k, but I don't go through k. I go through at most k minus 1 and take a star. That means I repeat in k, and then from k I go to j. So I start in I and I end in j, but in the middle I take care of any clean star operations. So this one plus union this one. Does it make sense? So this is exactly what I told. Either direct paths with nothing or via some state. Now that particular sum or one state or no paths is, or no states is generalized here. Let there are k minus 1 intermediate states. Let there are k minus 1 intermediate states. So one is that I start from I go to j through k minus 1 states. And another is I start from I take a break in k, and in k I repeatedly generate more strings on star operation if there are cycles, over the same state, and then from k I go to j. So this is essentially nothing but from I go to k, I wait at k, so that is kk, right? I start at k and end at k, and star, that means I take care of any cycles there, and then from k I go to j. So the net result is that I start from I and go to j, right? I take care of this path. And another is paths that don't go to k. From I go to j, right? Here I go to j only. From I have a path to go to j, but through k minus 1, state, if it exists in between. Now, my question is, answer me in a crisp way, yes or no. My question is, does this equation generalize this very simple understanding? Yes or no? Yes or no?
Yes, sir.
Yes, very soft yes, right? Okay, now, are you sure? Now, my next question is, are you sure that, okay, however soft it is, you are confident that if you go through books and if you go through the boards, then you will be 100% sure, is it?
Yes, sir. Actually, it will
Yes,
help
yes,
and
yes,
keep.
yes,
And
yes.
sir,
So
just one question.
yeah, 1 minute. Let me complete. Try to just visualize, try to just follow my words more than the board. You have to follow the board, but try to follow my words, what I say about this construction, how I ask you to perceive this construction. That is most important, because once you perceive and then you open books, that's the best way to study. Yes, your question.
Sir, not a question, sir. Rather a request, sir. Sir, could you like increase the thickness of the pen tip, sir? Because it's
I don't know why this pen tip is not increasing. See, the thickness is highest, right? I have
uh,
increased the thickness. Maybe my software is not working the way I intend to. But
Okay, sir.
see, this is just like this. Okay.
Okay, sir.
I will check it. I will check it once. Okay. But the concept, did you get the concept of recursively
Yes.
defining Rijk? Yeah. So this is in fact recursively defining Rijk in terms of k minus 1. See, all the indices are k minus 1. Right? So it says that if I have these values, k minus 1th level values, if I have these k minus 1th level values, I can derive the kth level value with this recursive formula. Got it? Yes or no?
Yes, sir.
Okay. So sometimes life becomes more simple if we take an example. So let us take an example, right? So somebody was asking a very interesting question last class. What about the strings that what about the language of this of a particular automata, right? Because we start with a particular automata and then try to find out the algebraic expression. So this algebraic expression is a way to find out all strings that take you from I to j. Now, the language of the automata is only such R, I, J, K values where k is set to the maximum state number, because you, no matter whether you start from I and end up at j, you should be exploring all options that take you from I to j, going through all such states, right? All intermediate states. So k should be n, I should be the start state, very simple, and j should be all such states that are final states. So I wrote something like j is an element of final states. So this is the language of the automata, right? So let me rewrite the language of the automata. It is union over j is an element of final state, regular expressions or algebraic expressions expressing strings that take you from start state 1 to all such final states, possibly going through all possible states. So I take care of all possible strings that take me from 1 to j. So my main intention is to take me from 1 to j, and I use labels. So the recursion should, we have used this recursive definition, and the recursion should start at some point, right? What is the base case? It is Rij0. So what is 0? What is the interpretation by the definition? It means that all strings that take me from I to j, not going through any state numbered higher than 1. But remember, we have numbered the states from 1. What is the higher number than 0? It is 1. So it means that all strings that take me from I to j, not going through any state at all. So direct links from I to j, right? And once you have this, you have an opportunity to derive Rij1, right? Along with some other requirements. So the rule of the thumb is to create all possible pairs of states. Like if you have 3 states, I will just show you a 3-state diagram. So you should be calculating R110, then R120, then R130. So 0th level, all R values should be at your hand, and then you go for calculating R111 using that recursion formula, R11121, like this, the ith level, the first level, and then you go for calculating R112, R122, R123, R122, right? And then based on that, you should be calculating R113, R123, like this. Got my point? So first step of recursion, the base cases. As usual, these are the base cases because I am only taking care of direct links. So I am not threatened by any cycles or any loopbacks. Direct links from I to j. That is 0. Not going through any state at all because the state numbering starts from 1. So if I am not permitted to go through 1, at least that means I'm not allowed to go through any link, any intermediate states. So direct links from I to j, if any. If there are direct links, I take care of those direct links from with Rij. If there are no direct links, it is phi. If there are direct links, it is symbol A, right? To start with. Because there are only 2 states I and j, and they should be connected with a symbol. If such direct links exist, and if no direct link exists, it should be phi. Very simple, right? So in a sense, you go get all the Rij 0 values, use this zeroth level values to calculate the first level values, use them to calculate the second level values, use them to calculate the third level values. And if I take a picture from the book, if you go through your book, there is a beautiful example given, and I will change the example also in due course of time to give you more confidence. So this is an example. I would request you to take down this example on your pen and paper with it, right? You have notebooks, right? So please take down this diagram, because I will immediately start scribbling through the diagram and the diagram will be not readable anymore. Please take down this diagram. Am I audible?
Yes, sir.
Yes, please take down this diagram. You have taken down this diagram?
Sir, is that 0, 1 at from Q3 to Q2?
Yes,
0,
it is 0, 1. 0, 1. 0, 1. Now my handwriting is not that bad, but I am missing that feel factor, right? I am not getting enough friction to write it properly because of the iPad screen and the pencil. The friction is less. It's a glass screen, right?
Yes, sir.
That's the point. Okay, did you take down this picture?
Yes, sir.
Okay. Now let us calculate for the zeroth level. So what do I mean by that? Let us solve this example a bit. The rest you should be solving it at your home. My responsibility to give you concepts, right? And how to work with concepts. So one is Q1. You started Q1. So we have named the states as 1, 2, and 3, right? Done. So what is R110? The string that takes you from 1 to 1, but not going through any state. That means not going through itself. You start at Q1, you come back at Q1, but you are not allowed to go through yourself. So there is no question of going through Q2 and going through Q1.
So epsilon.
So what is R11? It is epsilon.
Epsilon.
It is epsilon. I'm very happy. So you have got the concept of epsilon, right? So what is R120? What is R120?
0, 0, sir.
0, sir.
0.
Yes, very good. So what is R130?
1,
One,
sir.
sir.
1.
1.
1. Very good. So what is R? Now let me calculate 2, 1, 2, 2, and 2, 3, right? 2, 1, 2, 2, and 2, 3. Okay, tell me, what is R210?
Sir, 0.
0, sir.
0. What is R220?
Epsilon, sir.
Epsilon, sir.
Very good. What is R230?
1, sir.
1, sir.
Yes. Now, what is R310?
So that's epsilon, sir, again.
That is 5. That's 5.
5, sir.
There's
5,
no
5, sir.
1 from
5.
3, 1. Right? Okay. Okay. So what is R320? I take all possible pairs, right? What is R320?
So R3
0 and
0 and 1, sir.
0, 1.
How to write in an expression? So you are telling 0 or 1, right? So plus is or.
0
Yes,
plus
0
1.
plus 1. Right? Done? What is
Yes.
R330?
Sir, R330 will again go back to
Sir, epsilon.
epsilon, sir.
Epsilon. Done. So first level of values that you should be treating as your base cases, and then create the recursive process to generate R111, R21, R122, right? So this is K equal to 0th level. Done. So I and J and K all belongs to N, but K, where I and J should be greater than 0, but K can be equal to 0, right? Got my point? Why? Can you say why? Can you say why? Why K should be equal to 0?
Sir, we have considered the 0th level.
So base case.
Why? Yeah, base case, that is fine. So according to the definition, it's an interpretation that if R110 means you are not allowed to go through any state. So direct pulse.
Yes, sir.
So it is from the definition. But remember that at the end of the day, you should be having something like, see, 3 is a final state. So one part of your language is R133, right? So you start at 1, you end at 3 and accept strings, and you are going through all possible states. 3, right? So what are the number of states? 1, 2, 3. So I'm talking about going through. So I have 3 options here. And the other option I should be having, one extra option, is not going through any state, right? So that's why I start at 0, and then I iterate on 1 k values of 1, 2, and 3. Then these are for going through states, and this is for not going through any state. And this absolutely matches with the definition of RIJK, right? Done?
Yes,
Clear?
sir.
Now let us have this. So you are writing in your book, right? Now let us have this block of most simple values and then generate R111. So what is R111? Okay, let us check R111 intuitively from the diagram. What should be R111? What is R111? You start at 1, you end at 1, and you can go through at most 1, right? So in the picture it is Q1. So you start in Q1, you go to Q1, and you can go through your own self, right? So that is R111. But you are not allowed to go through any state numbered higher than 1. That is, you are not allowed to go through 2 and 3. So what is R111?
Sir, epsilon.
Yeah,
Epsilon.
it is still epsilon. Now see, the amount of time you spend to intuitively check and visually confirm that it is epsilon. Now, when you would be thinking in computer science, you should be thinking about automated steps. You should be thinking about writing scripts. You should be thinking about writing programs that are actually structured and that are actually a very mechanical way that should perform in a very mechanical way that should that should that should that should have no chance of thinking and then analyzing with a visual confirmation, because when you are designing machines, the way you are viewing this automata and drawing this automata on paper, that is not done inside the machine, right? That's why we'll apply these 0 values in this formula. We'll write some portion of code, for example, to run this formula and generate strings. Can you write a code for doing this? Of course, yes, right? Of course, you can write some lines of code to actually realize this formula and then mechanically go on substituting values for I, J, and K based on the fact that you have developed this in the most general form. Done? Yes or no? So no space for visual confirmation if you think yourself as a machine. And once you can think yourself as a machine, your purpose of learning computer science will be okay. So no visual confirmation from now. The time you took to check, oh, R111, okay, you are checking. No need, because we have already derived some formula. And we'll go mechanically. There is no need to rethink, right? Because thinking and visual perception gives errors. I will show you how. So put the 0 values here and calculate the 1 values. Simple. Now just think that you have an algorithm for this, a step-by-step way of doing it. It's actually a function evaluation, right? So R111, so how to put it in the formula? R111. So R111 is, so RIJK is nothing but, I gave the formula, right? So what is that formula? It is RIJK minus 1 plus RIK. You start at I, you go to K, but only through K minus 1 states. Then you start at K and remain at K, but through K minus 1. You start at K and come back at K, but through K minus 1. You are not going through yourself, remind me. But you are starting at your point, returning to your point, but going through lower intermediate states. Have a star, and then from that K you go to J, K minus 1. So here our K minus 1 values are zeros, right? So we need to calculate R111. So I equal to 1, I equal to 1, j equal to 1, and k equal to 1. Right? Plain substitution. R110 plus R110, R110 star, R110. Done. We have substituted I equal to 1, k equal to 1, and j equal to 1. Now what do you get? You get an epsilon plus epsilon, epsilon star, and then epsilon, because your R110 was in epsilon, right? So what does it come out? It come out as epsilon plus epsilon, and that is epsilon. And that is how you get epsilon. So no visual confirmation from now, because you have worked hard enough, you have applied your concept and built a formula with the objective that once you have the formula in its most general form, then you can just call that algorithm with different I, j, k values based on the fact that you have the base values. Very simple. Agreed or not? Yes or no?
Yes, sir.
Okay. Now please tell me what should be the value of R22K. R22K. R221, sorry. So R221 is R220 plus R. So here I is 2, J is 2, and K is 1, right? So it is R220 plus R210 plus R110 star plus R120. Is it okay? So immediately we see that till now we have all the zero values in our zero values table. So what is R220? R220 we had epsilon. So it is epsilon plus what is R210? You had 0. What is R110? You had epsilon. And what is R120? You had 0. So it is epsilon plus 0, 0. R221. Now, once you have this, since you are students and you are learning, you would have a tendency to verify visually, right? So you can do it now. I allow you to verify visually now. R220. Go through the picture and say that, okay, R221 is epsilon plus 0, 0. Let me go back here. Let me use the red ink and I will show you. So you start at 2, you start here and you come back here, but you are allowed to go through only this state. That is R221. You are not allowed to go through your own self. You are only allowed to go through state number 1. You start at 2 and you end at 1. Now, what comes out is epsilon plus 0, 0, right? We have to check whether it is okay or not. Done?
Yes, sir, yes.
Yes or no?
Yes,
Yes.
sir.
So,
Sir, I had one
yeah.
doubt.
Yes.
Sir, as for the stars that we're getting, epsilon stars we're getting, sir, instead of
Okay.
epsilon, it's, for example, 0, 1 star, would it be all the possible combinations of zeros and 1?
This one, you are pointing out this one. You are pointing out this one.
Yes, sir. For example, the R110 star,
Yeah. Yeah. It is
as
epsilon. Epsilon star. So what is
yeah,
epsilon
sir.
star? Epsilon star is nothing but epsilon. So 0 followed by epsilon followed by 0 is 0, 0.
So what if instead of epsilon star, it was let's say 1, 0 star? What
Yeah.
would our manifestation be then of that?
Okay. I will come. I will come. I will come. Please wait, right? I will come back. So I'm just talking about the 1th level. Let me go to higher levels, and then you will have higher expressions, right? I'll come back. Don't worry. Okay. So let us visually confirm this first. So we derive this to be epsilon or 0, 0. How? See, there is a path called 0. Then you are allowed to go through this. There is a path on 0. You are allowed to go through 1. You take another 0, 0, 0. Now, from where does this epsilon come from? It comes from that in Q2, you remain in Q2 on epsilon. This is a DFA and you are not allowed to change state. So you take care of this epsilon also, right? So what it means that I start at 2, I want to go to 2, I can go via this path, or I can still remain in Q2 without doing anything. So epsilon is doing nothing. Agreed? Yes or no?
Yes, sir.
So,
Yes? Yeah. So let me use another ink. So this is 0. This is 0. I don't know why my pencil is not giving me a thicker nib. 0. You are allowed to go through 1. Once you are allowed to go through 1, you take another 0. It is 0, 0. Done. Another way of thinking that I start at 2 and I end at 2 is doing nothing. Not follow this path. Doing nothing. Still, you remain in the same state on epsilon because this is a DFA and you are not allowed to change state on epsilon. So 2, 2 means I'm not changing state in that interpretation. So I take care of this epsilon. Now what is the need of this? You can say that what is the need of this, sir? The need of this is this DFA always has an equivalent NFA and always has an equivalent epsilon NFA. But since they are equivalent, their algebraic expression should be same. Such that my algebraic expression is the most general one and the most generative one. My algebraic expression for this DFA should be the algebraic expression for the normal NFA and the normal epsilon NFA also. Right? Got my point? So the rule of thumb is try to include epsilon wherever required from the way you are building. See, we are building things right now, right? Okay, let me come back to somebody asked me a very interesting question. What did you ask? What if we don't have an epsilon and we have something else, right? The question was, what if I don't have an epsilon and I have something else? Is it? Who asked me?
so I asked, so.
Yes. So, for example, what we can have in some higher k values, you can always expect some expression star where this expression is not as simple as epsilon, rather it's an algebraic expression, right? Because this is an algebraic expression, R11. Any value of k is an algebraic expression. You are taking a star. Now, what type of algebraic expressions you can have? You can have 0 plus 1. You can have 0, 1 star. You can have 1 star plus 0, 1 star, right? You can have anything, right? You can have anything, right? And then you have to calculate a star on that, right? Yes or no?
Yes, sir.
Yeah, so now what to do? 0 plus 1 star. Now, how to find out the values? What should be your approach? Should it be that you apply your you apply your intuition and then try to build strings, somewhat something like that? 0 plus 1 star. What should be 0 plus 1 star? So let us think of 0 plus 1 star. What are the strings? Let us think of this. The strings are epsilon. It may be 0. It may be 1. It may be 0, 0. It may be 0, 1. It may be 1, 0. It may be 1, 1. Now, in the course of deriving and making this set, see, I am following an order, right? And that order, you just go through things, and that order is called lexicographic ordering. See, I am ordering and writing things, right? Now, the algorithm to generate strings like this and ordering, you have to ask a question. So you can go for a plain simple algorithm to generate strings, but it's your duty, being a student of computer science, to ask a question whether this blind generation algorithm and then ordering is more costlier than any other simple algorithm, if it exists. So we are always in a quest to find out simpler algorithms if they exist. And those simpler algorithms should be fully supported by equations, replacements, generalizations, and taking care of all these three, we mean manipulation, right? Manipulation. What type of manipulation? String manipulation, algebraically. That is called algebraic manipulation. And algebraic manipulation is best supported if you have these three. You have equations, you can replace and you can generalize. And for that, you have something called a clean algebra that gives you rules to manipulate strings and to find out find out your and to find out equivalence. For example, you have a regular expression something like this: 1 plus r star. Now you are in a confusion how to reduce this. That means you are looking to manipulate this expression, to reduce this expression for better benefits, right? Now how should you go for this? Sorry, this should not be 1, this should be epsilon in our context. So epsilon plus r star. So if we go back to the definition of regular expression, I can very well replace these r's with single symbols, because single symbols are the base cases of regular expressions. So 0 epsilon plus 0 0 star. What should you do? One way is, the costlier way is to generate strings and see and check and order the set and check actually what regular expression talks about that particular set after your generalization. So it is epsilon, right? Epsilon, or 0 0 star gives you epsilon again. So I'm not writing it again. The minimum string of this 0 0 star is 0 0. Next, the next string that you can generate is 0 0 0 0. The next string you can generate is 0 0 0 0 0 0, something like this, right? And sorry, I didn't put a bracket, so I interpreted things. So it should be 0 followed by 0 star. So let us break up 0. So it should be 0 followed by the enumeration of the whole set. Let me write it like this. It should be 0 followed by, what is 0 star? 0 star is actually epsilon, 0, 0, 0, 0, 0, 0, all such strings, right? So your set should be containing epsilon and a 0 followed by this. So you need a rule to interpret this. You are not going to visually interpret this. So what is this talking about? What is this talking about? This is talking about that 0 concatenated by epsilon. What would happen if 0 is concatenated with epsilon? So your set looks like epsilon, or 0 concatenated by epsilon, or 0 concatenated by 0, or this 0 concatenated by double 0, this 0 concatenated by any number of zeros, something like this, right? So how to reduce this to confirm that 0 concatenated by epsilon is actually a 0? Should you wait for your confirmation to do this? Remember, your confirmation needs to be translated to a unambiguous confirmation by instruction in your machine. So you need to have interpreter rules pre-written, right? And those rules are given by some algebra. And that is, in this case, is a clean algebra. So epsilon 0 followed by epsilon is 0. That 0 followed by epsilon is 0. I should have an interpreter rule that would automate things. And what is that rule? In your algebra, you have a rule something like epsilon followed by any symbol is the symbol. This is some rule in your algebra. So when you are trying to automate things, when you are trying to replace things, you are trying to manipulate algebraic expressions, you should directly go and look up in the rule set and apply rules. So this gives you an opportunity to apply rules, right? Are you getting my point? So what is the set? How is the set looking as? Epsilon followed by 0, followed by 0, 0, followed by triple 0, followed by 4 zeros. So what is this set actually? This set is actually 0 star. Agreed? See,
Sure.
epsilon plus 0, 0, 0, 0 star. So epsilon, then 0 followed by this whole string. The 0 followed by a whole string means you are going to concatenate 0 with an epsilon, then concatenate 0 with 0, 0, right? Then concatenate this 0 with triple zeros and generate bigger strings. Now you need to replace, you need to have an interpretation. What is 0 followed by epsilon? You need to have a rule for that. Now it seems very trivial. That's why you might have a question in your mind. So why sir is talking about this rule? This is so trivial. But in fact, I'm talking about a bigger rule, not this rule only. I am talking about a rule that would say that epsilon plus 0, 0 star is actually 0 star. Now, this is not an accident, but this is a fact that epsilon plus 0, 0 star is 0 star can be derived from a clean algebra rule that reads as epsilon plus r star is r star. This is a rule in clean algebra, right? To talk about clean algebra in a more generic way, that algebraic structure, you can say it is 1 r star is r star, and in our case, clean algebra when interpreted, this is a clean algebra rule. In our case, when this clean algebra is thought of in regular languages, we are going to. Hello, can you hear
I
me?
think the screen is no longer visible,
Sir,
sir.
your screen is not visible.
So why my screen? How long it is not visible?
Sir, just now, sir.
Just now. Okay. Okay. Somebody else is presenting. So just now, right? So my see. There's a very. I thank the person who asked this question, because this is a very interesting question. So let me say that okay, 0 plus 0, 0 star. If you have this situation that you have something like epsilon plus 0 followed by 0 star, right?
Sir, I
So
don't think the
what
screen
should
is
be?
still visible, sir.
My screen is not visible.
No,
Still
sir.
not visible, sir.
Why? Why? I've shared my screen. I'm seeing a message that somebody is presenting.
Uh,
Who is that? Let me check. Let me check it once. Now, is my visible?
yes, sir. Now it's visible,
Yes,
sir.
sir.
Yes, sir.
Okay. So he asked me a question. Let me just go back to his question, because it's such a beautiful question. So he asked me a question. What if I don't have some simple thing as epsilon? What if I have an expression? You can have an expression because you have an expression really, right? This is an expression, right? This is a regular expression R110. Now that expression, I talked about that you can have such and such expressions. Now let that you have an expression. I complicate things a bit, right? So let that you have an expression like this: epsilon plus 0, 0, 0 followed by 0 star. Now one way of doing is to enumerate all strings and form a set and then order it and then check what regular expression expresses this set. So that is one approach, and that approach you can do some paper arithmetic on paper and say that okay, so this is epsilon comma 0 followed by 0, 0, 0 star. So I enumerate 0 star like this. It is epsilon, then 0, then 0, 0, triple 0, dot, 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 dot. It's an infinite set. And then you do some concatenation. 0 dot epsilon, 0 dot 0, 0 dot double 0. Now what I argue is, now once this process of simplifying expressions is an algebraic process, right? Now if you have a rule that says that okay, you can go for that rule and substitute 0 in place of s and you get a 0, right? So you apply that rule. Now you may have a question in mind that 0 followed by epsilon is a very trivial thing, and why we need to look up to an algebra, right? Yeah, really there is no need, because it is very obvious. But what if I say that the whole process is more costly? The algorithm to enumerate 0 star, you need to have an algorithm to enumerate 0 star. Then you need to have an algorithm to do the concatenation. And then the most costliest part, given a set, you have to find out what expression expresses this set. Remember, you are not given a DFA, right? You are given a set. So you have to check each and every element of the set to determine that, okay, this is actually 0 star. And that point I argue that what if you have a set of algebraic rules and you have a rule like this, that if you face something like epsilon plus, if you face something like epsilon plus 0 followed by 0 star, you can simply replace that by 0 star. And actually, you have a rule in clean algebra, the algebra that is free in nature and that has the best interpretation in regular languages. The structure that I was talking about, some clean algebra, Ka with operators plus concatenation star and 0 and 1. And that clean algebra, you have a rule that says 1 plus r star is actually r star, sorry. This
So, so,
Sir, you are not audible.
hello, hello. I'm sorry, I
Yes,
got
sir.
disconnected. Yes, I'm very sorry, I got disconnected. I reconnected once more. Let me come back, and I will end today's class in 5 minutes. Okay, just let me talk about this concept. So I'm very thankful for the question. So what I was, now my screen is visible, right?
Yes, sir.
So I was talking about some clean algebra. If you remember, I was talking about some clean algebra some time back. I didn't get scope to talk about this much, but this algebra is actually the algebra for regular expressions. It integrates seamlessly with our interpretation. So let regular expression be an algebra over plus, dot, and star, where plus is the union operation, star dot is the concatenation operation, and star is the clean closure. And then you interpret 0 as a phi, 0 of the algebra, the free algebra, general algebra, as a phi in our case, and 1 as an epsilon. And in that algebra, you have a rule that says that an expression like 1 plus r star can be just substituted as, can be just replaced with something like r star. Now, if we have that algebra, imbibed in our algebra, and we represent 1 with an epsilon and 0 with a phi, the 1 of the algebra is epsilon in our regular expression algebra, then we can say that, okay, epsilon plus 0 followed by 0 star, we replace r with 0 by 0 star. So if we have a rule, then the costly algorithm to determine epsilon plus 0 0, and to minimize epsilon plus 0 0 to 0 star was based on this enumeration, then ordering, and then there was a very vital question. Does there exist an algorithm that would convert this set? Remember, this is an infinite set, right? And is there an algorithm that exists that would convert this this infinite set to an expression? That's a very, very important question. And if only the answer is yes, then the way that you reduced epsilon plus 0 followed by 0 star to 0 star is actually applicable in computing. Otherwise not. Otherwise it is good with a pen on a paper, right? Got my point? But if you have this rule in some algebra, and if you can define that structure mathematically and computationally, then you can always reduce expressions of this form to there. And such algorithms can be designed. Algorithms for structures and algebras can be very well designed and defined. Got my point? So, in fact, if you have such an expression inside your regular expression, so you are doing something equal to something plus something, and here you have epsilon plus 0 0 star star something. Yes, these are regular expressions. So he actually asked, what if we have something like this? The best way is, if you have an algebraic rule, directly substitute. And if you don't have an algebraic rule, search for other algebraic rules, because those are only finite algebraic rules, where you can substitute portions of this whole expression into other algebraic rules to derive other expressions. So algebra gives you an immense opportunity to derive other expressions from smaller expressions or different expressions. Got my point? So if you guys are interested, I can take a special class on clean algebra, because I think that is very important for your concepts. So you go back through the book. This example in the book, you can find the example in the book, and you can find a lot of things that are not in the book from my board. I will share the board like you have suggested. And just give me one extra class. I want to take a class on Monday. Can you give me an extra class on Monday?
Sir, I have a doubt in the above example.
पहले बोलो, Monday class हो सकता है?
Sir, if you can take in the morning time, then
Yeah.
it will be okay.
Yeah, I will take in the morning time. Yeah, but you are sure that all of your friends are not going to exhaust their data packs? Please talk with them once, because I don't want. I don't want.
3 periods.
Yeah.
Other all days we have 4 periods, sir.
Which one?
So Monday is the only day in which we have just 3 classes, and other days we have 4 classes.
So give me a time. At what time shall I take a class on Monday?
So about 11:45 to 12:25.
Yeah, I am there. Right? So we have a class on Monday. Okay. So which one did you not understand? Epsilon plus 0 followed by 0 star?
Sir, in the example where you have calculated R221.
R221. Okay, then I have to go back. Oh, R221. Where is R221? R221. Yeah, R221. Yeah.
From this equation, we can say there are only two possible strings, no sir, epsilon and 0 0.
Yeah. There are only two possible strings. Very good. There are only two possible strings. Yeah, let me complete. There are only two possible strings that take you from 2 to not going through 2 and higher states.
Sir, but we
and I can 1 minute. Let me complete. So writing in other terms, what I say is from 2 to 2. I don't know why the pencil is such thin. From 2 to 2, not going through any state number as high as 2 and high, can be written in some other way as from 2 to 2, going through at most 1. That in fact includes strings that take you from 2 to not going through 1 also. Got my point? Now this includes this. You have recursively built this on this. So it includes, so I need to go from 2 to 2, right? Let me zoom in. I need to go from 2 to 2. I am allowed to go through 1, but that I am allowed to go through 1 should include that I am not going through anybody. I am not going through 1 also, right? So in that sense, you can say, and to generalize such that this expression seamlessly represents the equivalent NFAs and epsilon NFAs. What you say is that, okay, this is, so let me go back to the diagram. Why did I draw the diagram? Here. So here you can say that I start at 2. You are looking to the board. I start at 2 and I end up at 2. I am allowed to go through 1 at most. But that means I take care of strings which doesn't go through 1 also. So R2 to 1 means all strings that take me from 2 to 2 at most going through 1. And that at most going through 1 contains all strings that take me from 2 to 2 not going through 1 also. So R2 to 1 contains R2 to 0. So what was R2 to 0? It was epsilon, right?
Yes, sir.
Remember? So that way you have epsilon plus 0, 0. Did I satisfy your answer?
Sir, but can we means 0, 0, 0, 0, 4 zeros also?
No. You cannot have 4 zeros, right? Why? Let me answer this and I will leave. Okay. So, but again, there is a very good question, but this question you need to look to the picture once more. So it was Q1. What was it then? It was a 0, right? That takes you to Q2. And then you had a 0 or 1. You had a 0 or 1. I again have to scroll up. You
Sir,
had
from
a
Q2 to Q3,
to
1,
Q3.
sir.
You had a 1, right? You had a 1, yeah. And then Q3. Then you had a 0, 1 here. And then you had a 0 here. And that was the picture. I had a 1 here, right? Yeah.
Yes.
So you are asking, you are convinced that R2 to 1 is epsilon plus 0, 0. Now you are asking, why not epsilon plus 0, 0 followed by 0, 0? Why not this, right?
Or
Why I'm not talking about
epsilon
this?
also,
Or
sir.
multiple, right? Because 0 then going through 1 that you are allowed. This you are calculating R2 to 1. You are allowed. You cut through this state and then take another 0 to reach 2. So you start at 2, you end at 2 on a 0, 0. If you have to get 2 more zeros, you need to cut through 2. You are not allowed to go through 2. You are calculating R2 to 1. If you are allowed to go to 2, then you would be calculating R2 to 2. Right? And R2 to 2 from visual confirmation is 0, 0, 0, 0. So it is 0, 0 star. So R2 to 2 is you start at 2, you start here, you end here, and you are allowed to go through 1, go through 2. Actually, it is go through 2, that includes going through 1, that includes going through none. So it includes going through 1, R2 to 1. That in turn includes going through none. That is how the recursion works. Can you visualize? So R2 to 0 was epsilon. That epsilon was included in R2 to 1, epsilon plus 0, 0. Now that epsilon plus 0, 0 is included in R2 to. See, if you break up this, you have epsilon 0, 0, 0, 0, 0, 0, everything. So epsilon plus 0, 0 is included in R2 to. That means R2 to 1 is included. See, this epsilon is included in R2 to. That means epsilon is included here. So it's an inclusive design, and that's the design. That's the main thing that you achieve via recursive way of generating strings. It gives you the guarantee that okay, you generate only if it exists. So R2 to 0, R2 to with R2 to 0, you build now how to calculate? If the computation part is just the opposite, right? So this is the This is the theoretical way of thinking, and computing means you generate this. This is the easiest thing to do, to create this as the base case, and based on this you derive a formula. You put this value in some formula to generate this. Then once you have this value, you put it back in that formula to generate this. And that is actually that formula, right? Rijk is Rijk minus 1. And then you, from I to k, you go over k minus 1. From k, you go to k, but only through k minus 1th level. And then from k, you go to j, but also at the k minus 1th level. So this is a pure structure of generating the kth level strings based on the k minus 1th level strings. Does it satisfy your question?
Sir, is it the same reason for not having multiple epsilon also? Epsilon.
Multiple epsilon is epsilon, right? Epsilon followed by epsilon followed by epsilon is epsilon, right? Epsilon star is epsilon.
Or 0, 0 epsilon 0, 0. That
0, 0 epsilon 0, 0 epsilon 0, 0 is 0, 0, 0, 0. Now this is very easy to visually confirm. Now if I talk about a rule for in that clean algebra, say 1 dot some expression r is that expression. Another rule, this is rule number 1, and another rule is r followed by 1 is r, and that clean algebra when interpreted in the regular expression algebra, I just replace these ones with epsilons, right? And it holds true. So I talk about something like this: epsilon followed by r is r followed by epsilon is r. Now this is very obvious, this is a very trivial thing, but you when you are asking, that means you are not in a position to visualize this, right? So you go by rules. That is what I'm talking about. The most mechanical way, you apply rules, you write an algorithm that would call rules, that would check rules and apply. So r, you replace r with 0, right? 0, 0. 0, 0 is your r, right? That is what you were asking. 0, 0. So epsilon followed by 0, 0 is 0, 0. And 0, 0 followed by epsilon is 0, 0. Got it?
Yes, sir.
Got it? Yeah. So if you think algebraically, mathematically, what this epsilon looks like. Well, okay, if zero of the clean algebra is thought of as phi in your regular expression algebra, what that 0 signifies? It's annihilator, right? Phi is annihilator. Phi followed by any expression is phi. Any expression followed concatenated by phi is phi. Those are called annihilators. Just think of your discrete maths classes. Those are called set annihilators, string annihilators. And what are these called? 1 followed by expression is that expression concatenated by 1 is that expression. 1 in our case is epsilon in the case of regular expression. What is that called? Identity, exactly. That is what is called identity element, right? So if you guys are interested, you can just tell me. I can take a class on clean algebra, right? So that ends today's class. Basu is there. Basu, are you here?
Yes, sir.
Yeah. So Basu, somebody called Gulshan Kumar Chaudhary requested me to add up his email ID. So I think I had sent him this link. Please check whether he attended today's class or he is facing any more problems. And Partho Bhomik also, whether he is attending. I have sent their emails also. I've sent the links to their email IDs